Okay, so this is the example that we went through in class again when we're looking at some of these measures of variation for financial, particularly for financial data. So let's load in our friendly growth value. And we can see this is a data set that we've seen a good few times before, so I don't think I have to explain it, but yearly return for growth and value funds. Let's just kind of now let's just do a little bit of let's just do the summary again. So let's just do the summary of my data, and then we get these kind of quartiles. Remember the third quartile and the third quartile. Now Excel actually has a function that can do percentiles, and that function is called quantile. And literally all you would do is you would pass it, for the basic version of the function, just pass it the actual proportion for the percentile. So let's just try and get the 30th percentile. And we can see the 30th percentile for growth is 0.3, and for value is, sorry, the 30th percentile for growth is 6.92, and for value it's 7.85. So it's slightly higher for value. Now let's actually go and let's do the 25th percentile, just to see that it matches. And you see 2.86 for growth and 1.7025 for value, and you see it matches with the information given in the summary. We could actually do the same with 75, and it should match the third quartile. So we have 36.97 for growth and 22.44, and again matches the information in the summary my data. So this was just showing you that you can explicitly call the equivalent of the percentile function in Excel in R. Okay, so we also talked about measures of variation. So let's just kind of have, the first is the range, and we'll do that for both growth and value. So we'd have, let's just go back and do the summary. And we can actually give, basically there's a maximum function and a minimum function. So you get both of them, and then you get the range. And you could see here from growth, the range would be 79.48 minus 40.90, which would give 120.38. And for the value function, for the value funds, it would be this value minus this value. And again, we could also get the interquartile range, which would be the difference between the 75th and the 25th percentiles. We'll do that for both value and growth. And again, we could kind of compare it with the data in the summary. You see 36.97 minus 2.86, 34.11, and 22.438 minus 1.702 would look something like this value here. Okay, and a few other values that we have. We have the mean absolute deviation. Remember when we did the variance, I said the absolute the straight deviation was going to cancel out, but you could either square it or do the absolute value. All this function does is, so say for example we have for growth, let's just do growth and value. So for growth, the mean of the growth is 15.755. We have all the growth values here. And then we just calculate each of these growth values minus the mean. These are the absolute deviations. These are the deviations. Then we can absolute value these. And then we can calculate the mean value, or we could even do the sum. And so we get for that, for the growth, we get 17.49. And for the value, we get 13.67. Now, what we could do is we could actually replace the ABS with a square. So we get the square difference between the values and the means. So here we are. You saw below before, the absolute difference for the first one was 21.255. Now the square difference is 451. And if you divide it, assuming we're calculating the sample here, if you divide it by the number of items, so the number of items, I just put the length minus 1. This actually gives you the variance, just the sum of the squares divided by n minus 1. It gives me the sample variance. But of course, it's much easier to utilize R's built-in functions. So we can just use the variance, which automatically goes to the sample variance, or the standard deviation, which is the square root of that, and then the same for the value funds. Okay, so now we've done measures of both dispersion and of central tendency, so we can actually compare them. So we have from page 92, we have the coefficient of variation, which is just a measure of the ratio of how much risk there is relative to the actual value of the asset. So, and this is just the standard deviation divided by the mean. And you can see there it was 1.51. So the growth for growth and 1 almost 5 for the value. So the growth has a little bit, the standard deviation, the risk in the return for the growth relative to the mean annual return is slightly more for growth than for value. We can also calculate the Sharpe ratio, which again is just the mean return minus how much return a treasury asset we get. We've said this is 2% a year, divided by the standard deviation. So it's just risk adjusting for a risk-free asset and adjusted for standard deviation, just the level of return. And on this metric, we see that the growth fund on average has a slightly higher level of return. Okay, so these were kind of basic and we went through them in class, but again, just it's useful to go over these just so you've got the basics of calculating things like means and standard deviations and percentiles and stuff like that.